Okay, vectors. We've got two non-zero vectors, A and B. Now remember, a vector is something that has both a size or a magnitude and a direction. And we need vectors when we're looking at mechanics, where we might need to consider things like forces, velocity, and so on, where the direction is as important as the actual magnitude. So we can represent vectors by arrows going in a particular direction. So if I say that's a vector A, and we might have another vector like that, and we can call that one vector B. Now, where we've got two lines around the vector like that, that means that's the magnitude of the vector A. In other words, if we've got a vector represented by an arrow, as we've represented A, then the length of that arrow will be an indication of the size of it, and the length of it will be the magnitude of the vector A. So, I mean, I could label it with a 6, say, and that would be a vector with magnitude 6 going in the direction of this line, of this arrow which I've drawn. Right, that's just an example. So what the question asks us is, the two vectors, it says the two vectors are such that the magnitude of A plus B is exactly the same as the separate magnitudes of A and B added together. Right, well, the first thing we need to think about is what we mean by addition when it comes to vectors. And if I use the two vectors I've got here, vectors A and B that I've drawn here, then if we want the vector A plus B, what we can do is I can redraw vector A. I'll do it in a different colour. So I'll redraw vector A, and it's got to be about the same size and going in the same direction as I drew it in the first place. Now, it doesn't matter where I put this vector A, but in order for it still to be the same vector, it needs to be going in the same direction. So it needs to be the line needs to be sloping at the same angle, and the same for B. But if I want to know what A plus B is, then I start by doing vector A. Now, where vector A finishes, or where the arrow representing vector A finishes, at that point there, that's where I can start drawing B, going again in the same direction. So I'll then draw another arrow, which is going to be parallel to the arrow that I drew for B. So it's going to look something like that, and it's got to be about this. Well, it's got to be the same size if it's the same vector. So it's about like that. Okay, so there's vector A. Where vector A ends, we can start drawing vector B. The directions of these lines are the same as the directions where I first drew them in blue. Now, the vector A plus B is the combined result of doing vector A followed by vector B. So the vector A plus B we can represent by another line starting where A starts and going up to where B finishes there. And that vector there is the vector A plus B. Now, in general, okay, in general, the magnitude of this line here, the magnitude of A plus B, you can see in general is going to be less than the separate magnitudes of A and B added together. Right, the only time when the magnitude of this line on the triangle is going to be equal to the sum of the magnitudes of the lengths of the other two lines on the triangle, the only time that's going to be true is if vectors A and B are going in the same direction. Because if they're going in the same direction, then when I come to do a plus b, there won't be any angle between them. It'll just be a continuous straight line. Right, so in general, the magnitude of a plus b is not the same as the magnitude of a plus the magnitude of b separately. The reason for them not being the same is because we need to take the direction that the lines are going in into account, which we don't have to do with normal numbers. However, this is a special case. This is a special case where the magnitude of a plus b is the same as the magnitude of a plus the magnitude of b, and the simple answer to part 1 is that the geometrical significance is that the vectors a and b are in the same direction. Okay, because if you think about it, the only way that the third line of a triangle is going to be equal to the sum of the other two lines, the only time that can be true is if the other two lines are going in the same direction. Okay, now part B, it gives us a new situation, part 2 gives us a new situation, and it tells us about some more vectors, the vectors m and n. Right, and it tells us that the vector m has a magnitude of 3, and the vector of m minus n has a magnitude of 6, and it also tells us the angle between the vectors m and n is 30. So if I try and do a sketch, I'll start by doing a vector m, and this is just a sketch. I don't know what direction it's going in at the moment, so this is just a sketch for my working out. But this is vector m, and we know that it's got a magnitude of 3, which means, another way of saying that the length of the line representing the vector m is 3. It then tells us we've got another vector n. It doesn't tell us much about n, but it does tell us that m minus n is 6. Well, if I have my vector n, supposing my vector n is coming off like something like that, okay? So there's my vector n. It tells us that the angle between m and n is 30. So make it a bit clearer. Let me rub out the 3 there, and I'll write it in here. So then I can write the angle between them is 30. Okay? It also tells us the vector m minus n. The magnitude of the vector is 6. Now what is the vector m minus n? Well, if I start here and I go to there, then I've gone n. If from the end of n I then go along like this, to there, then that vector there is actually the vector m minus n. And the reason for that is because, do you remember before I said adding vectors means you go along the first vector? So if I start here and I go along vector n, if I add on this vector here plus m minus n, then I get to this point here, which is the same. Let me highlight it. I get to this point here, which is the same as if I'd have just gone along this vector m. And that makes sense because look, n plus m minus n, well, the n's are going to cancel out, so that's just vector m. Okay, so I've just explained to you why the third side of the triangle here is going to be the vector m minus n. But we know the magnitude of that is 6, so it tells us, in other words, the length of this line on the triangle is 6. What we've got to do is find the angle between m and m minus n. So we've got to try and find this angle here. Oh, and that's it. Yes, giving our answer in degrees. Right, so let's have a look. What have we got here? Well, I think we can use the sine rule to do this, because if I use the sine rule, I can work out what this angle here is, can't I? Because if I call this angle here theta, then the sine rule tells me that sine theta divided by 3 is the same as sine 30 divided by 6. Okay, and that means we can get a value for theta. When we've got a value for theta, we can add it to the 30 and then take it away from 180 degrees, and that should give us this angle in red, which is the one that we want. So sine theta equals, now sine 30 is a half, so it's 3 over 6 times 2, which I think is 0.3 over 12 is 0.25. Okay, and if sine theta is 0.25, that means that theta is going to be equal to the inverse sine of 0.25, which you can do on the calculator, and it comes to, I think, to 14.5 degrees, and therefore the required angle equals 180 minus 30 minus 14.5, which equals 135.5 degrees.